So to begin with, here the statement was, when we say that y equals to f of x is a function of x, then we mean that for every value of x in the domain of f, there will be a unique value, unique y value, that is one and only one y value under f. So here there are two very important points, one star here and one star here. Okay, so for every x value, this expression should be able to give you unique y value. For every x value, this expression, if it is capable of giving us unique y value or unique f of x value, then you will say that this is a function of x. Remember students, f of x and y are one and the same thing because you are writing y equals to f of x. To make this more clear, let us have a very simple example. So here I have taken one very simple example which will make you understand, if at all anything so far discussed you have not understood. If anything so far discussed is not understood, then you will understand in this example. For y equals to 2x, we can say that y is a function of x. Okay, so for this expression y equals to 2x, I can very easily make such a statement that y is a function of x. Why so? You can check. I have made a table here, and in this table you understand that the first row is x and the second row is y. The first row is x and second row is y. The first row you are getting the values of x. So when I substitute x as 0, I get y equals to 2 times of 0. See, what I am doing is I am deciding one x value, and that x value I plug in this y equals to 2x, the expression 2x. Now when I do so, I am getting 2 times of 0 as 0. When I put x as 1, I am getting y as 2. Notice students that when I am putting x as 1, I am getting 2, and which is unique value, and that is what we had underlined here. See, we should get a unique y value every single time. What I want to tell you is, if y equals to 2x, if y equals to 2x, you substitute x as 1. Every time you substitute x as 1, you will get 2 and 2 only. So this becomes a unique y value for this specific x value. So if I'm putting x as 2, I will get 4, which is unique. It just cannot happen that I'm putting x as 2 in this. It just cannot happen that I'm putting x as 2 in y equals to 2x, and sometimes I get 4, sometimes I get 5, sometimes I get 6. It is not possible, students. You know, you will every time get 4, which is unique. So when x is minus 0.5, you get negative of 1. When x is negative of 1.7, you get y as negative 3.4. So what you understand is, for every x value, see, that word every is coming here. For every x value. How is that coming? The moment you think of one x value for which the function is defined, for that x, there exists a unique y. There exists a unique y. Okay, so here it is written. Here we notice that for every x, there exists a unique y. You can check. You think of one real x value. I give you one assignment. You think of one real x value, and for that real x value, check whether you will get 2 times of x or not. Definitely you will get whatever x value, may it be very large positively, may it be very less negatively. If it is some real number, then you will definitely get for that real number the y value, the unique y value or unique function value. Okay, students, let's go ahead. There are some more pointers to be followed. In the above table, we notice that values of x are independent. Values of x are independent. You noticed you can substitute whatever x value. See students, here I am given you a very simple example of x, very simple example of function of x, which is a linear algebraic expression. But remember, such a thing which I'm making you understand, it is just for the sake of simplicity which I went for such a function. But the same thing is true for trigonometric function or logarithmic function or exponential function. The only difference will be that when it is trigonometric function, the nature will be periodic. That we will see in lectures to come. For now, you have to understand the basics of 1 onto function, which we are going to very slowly arrive at. So on the basis of above table, there are certain points which I have written and you all have to understand. In the above table, we notice that values of x are independent. What does that mean? It means that when you are having y equals to 2x, a function of x, the values of x are independent. You can substitute any value of x from the domain of f. From the domain of that function y equals to 2x, the function mathematical rule, any value of x you can substitute, any real x value you can substitute in y equals to 2x, and for that you get some y value. So the x values are independent. Values of y are dependent on values of x, and values of y are depending on values of x. That is very much clear. X is known as independent variable and y is known as dependent variable as it depends on x. I hope this you all are understanding. Students, you have to make note of each and every point which I have written, and if any doubt you have, you can always comment on that and you can ask me the doubts. The next point is the underlying rule that decides or gives the unique value of y for a specific value of x is called the function. And since the rule is applied on x, on values of x, hence it is also called as function of x. Consequently, it is denoted by f of x. Since this f of x is the values of y, hence we write this as y equals to f of x. Okay, students, let us read this once again. The underlying rule that decides or gives unique value of y for a specific value of x is called the function. Okay, students, the underlying rule, what does that mean? Let me ask you a question, students. If I am substituting x value to, okay, please listen to this. If I am substituting x value to here in y equal to 2x, I am substituting x value to in y equals to 2x, and then I am expecting y value to be 16. Is it possible? Never. If I'm substituting x value as 2 and I'm expecting y value to be 8, is it possible? Never. No. What I'm talking is all senseless things. Why? Because when I'm writing y equals to 2x, I have already defined a mathematical rule, underlying mathematical rule. And what is that? The rule is every y value is going to be double of the decided x value. And remember, students, this underlying rule, because of which you are associating for every x value a unique y value. Every x value you are associating a unique y value is because of that underlying rule, and that underlying rule is only the function. That is the function. So once again, here the underlying rule that decides or gives the unique value of y for a specific value of x is called function. Further, and since the rule is applied on the values of x. Where are these rule applied? These rule are applied on the independent variable x. Every single time it is the x value which comes first. So the rule is applied on the values of x, hence it is also called as function of x. It is also called as function of x. Remember students, the rule here which we are applying, if instead of x variable, had it been some other variable, say it would have been p, then we would have said that this rule we are applying on the variable p, and in that case we would be calling this as function of p and not function of x. Further, consequently, it is denoted by f of x. Since the underlying rule which we are calling it as function and denoting it by f, it is applied on x, so we can call this as f of x. Since this f of x is the value of y, hence we write y equals to f of x. Remember students, you write f of x or you write y, it is one and the same thing. I want that you repeat this video once again, replay this and learn it thoroughly. The next part will come in the next video. The concept will be continued in the next video. Thank you.